Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
This episode of the IoT Spotlight is brought to you by the Industrial Internet Consortium, which we often refer to as the IIC. The IIC is the world's leading organization transforming business and society by accelerating the industrial Internet of Things. IoT One has been a member of the IIC since 2015, and I've personally always been impressed by their ability to facilitate collaboration between companies to bring new technologies to market and to jointly address topics like security and system architecture, which are fundamental to scaling IIoT adoption.
Welcome back to the IoT Spotlight podcast. I'm joined today by Jesus Molina. Jesus is the Director of Business Development at Waterfall Security Solutions. He's also the co-chair of the Security Working Group for the Industrial Internet Consortium, or the IIC. And today with Jesus, we'll be discussing cybersecurity and how you can, in practical terms, whether you're a device manufacturer, a system integrator, or an end user, approach security in an industrial environment where it's closely linked also to the reliability of critical systems and to the safety of people. And so that's quite different, of course, from a back-end IT system. Jesus, thank you so much for taking the time to talk with us today.
Thank you for having me.
Great. So, Jesus, before we kick off the discussion, can you just give a brief introduction of Waterfall Security, and then why is Waterfall and why are you involved in the Security Working Group at the IIC?
Let's start with my company, Waterfall Security Solutions. Waterfall Security Solutions is a company that has been around for quite a bit of time. We were founded in 2007, and at the beginning, Waterfall, what we did is to secure nuclear power plants. After some time, my company continued developing its products, which I will discuss a little bit what exactly we do. And we started protecting the energy sector. So we went to all the substations, etc., to protect that vertical. In the last 10 years, we have been moving to other verticals. Lately, we are working quite a bit in transportation, in rolling stock, and also in signaling systems. My company works with the premise of protecting systems is more about understanding what you have in your premise and able to send only the information that you require in order to be evaluated, rather than having a completely networked system. I will discuss a little bit later about our core product, which is unidirectional gateways. Now, about me, let me talk about, as you mentioned, I am the chair of the Industrial Internet Consortium in the Security Working Group. And my path to get there is a little bit interesting, I believe. So let me discuss this a little bit, because also it tells a story of when I started doing that research and work first with Fujitsu. For a while, I started doing penetration testing of systems such as smart meters. Smart meters were hot like 10 years ago, of one of the first devices that got connected. You know, you have all these smart meters and they don't want to your house, so they start receiving information using wireless. And interestingly enough, I found a lot of bugs, the first iteration of IoT, how we know it, or industrial IoT, because actually meters our IoT. One of the bugs I found is a way to kill the electricity of your house remotely. So I was able to find the code that really did the kill switch, you know, that like it was able to shut down that smart meter. That is interesting because I didn't even know that could be done. So that is interesting because all these and this little device, the idea here was to just receive the data from the smart meter. As it turns out, there was some functionality. So if you don't pay your bills, you can shut it down remotely and take your electricity with. So it's with consequence, obviously, because now I knew that I could like shut down the electricity of smart meters if I knew that was the brand. I'm not going to mention or say exactly what happened there. But that also got me interested on all this IoT, industrial IoT, and I did quite a bit of research on it. And one of my main, I would say, main stories that appear in the media quite a bit is the day I was able to take control of a hotel. I was in a room of a hotel in China, the San Regis station, and this hotel, which was very high tech, every feature of the room was controlled by an iPad. So you can, with the iPad, switch on the light, switch off the lights. You can put music. You can change the outside light. You can change even use it as a remote control for the TV. So while I was staying there, Eric, I decided, because I am the nerd I am, the pool and I understand that this is a 5-star hotel is in the top 20 floors of a 100-story building. It's amazing. It's amazing. It's just like stunning views and even the bathroom. When you sit down to do whatever you need to do in the bathroom, you were looking down to this huge floor to ceiling windows, looking at people that look like. But anyway, so I was there in this beautiful room, and I decided to see if I can replicate the functionality of the iPad using my Mac. And I started doing it and like working on it. And after one day of heavy drinking and fun, I was actually able to replicate the functionality of the iPad and control and make little like lights movements and put channels in certain patterns and do little things like that. First, let's understand this a little bit, because you're saying, why you're asking me, we were supposed to talk about industrial IoT. Well, first, the protocol that this hotel used was KNX, which is an industrial protocol. So as you see that they were using an iPad, which is a consumer electronic, to control a building using an industrial protocol. And the industrial protocols, as it turns out, don't have any authentication, and they don't have any cryptography whatsoever. It has no crypto, no authentication of the devices. So once I was able to control my room, what I did is I started calling downstairs to the whatever it is, the registration desk, and I asked them to change my rooms. So Eric, I said, "Oh, can you change another room? I don't like this room." So I went to the room and I did the same experiment, and I did that in 4 rooms until 2 things happened. First thing, I discovered a pattern so I can control the 200 rooms of the hotel. And the second thing that happened is that they upgraded me to the best room of the hotel because they were so tired of me,
Oh, interesting. So by moving between rooms, you were able to hack in each room individually and then understand what were the variables that were room specific, and that allowed you to understand the pattern for the hotel as a whole.
Exactly. And with that, I created a program that I was able to raise every blind of the hotel to at the same time, the 200 rooms of the hotel I could raise all the blinds, like Magneto style, right? Just go there and say like, oh, everything raised, and switch off every TV to whatever channel I wanted. So anyway, it was nice. I got the best room of the hotel first. I was in this duplex in China, because I did that. And second, I learned, that the security of the current systems, as they were, was really bad. And I have to put that as an aside, saying that the Starwood, which is the company that has San Regis, were incredible on their approach to that. Instead of blaming me or anything, they were very open to understanding why they have failed. And I was able to present my work.
You're explaining the difference between, say, IT, IoT, and industrial IoT. And I think that's a critical differentiation to make. And then in this case, the hotel case, I think a lot of people might consider that to be an IoT situation. But from your standpoint, the technology used there was industrial IoT. How would you look at that within this kind of these 3 different tiers? How would you look at that particular case?
Actually, my point here, and that's interesting that you mentioned that about, you are saying the technology was industrial IoT, and that's what makes it industrial IoT. I believe what makes something industrial IoT or IoT is the characteristics of your project. For example, if you are trying to connect a Barbie to the cloud, what you are more interested to in terms of security is that it doesn't really affect that you conserve the privacy of the person that is connecting the Barbie to the internet. There is a Barbie actually that we'll talk about later. But your main focus here is usability. You want this person to have fun with the Barbie, right? You want this person to be able to use the Barbie and buy the Barbie because it's fun, right? You don't want to make them like put certificates in the Barbie or all that stuff. You have to conserve privacy, obviously it's very important, but your main focus will be that the Barbie is usable. So that's a consumer IoT because you have a characteristic there that is making sure the person with the Barbie is happy that you're using it. When you go into industrial IoT, the characteristics are very clear. Usually it's about reliability. It's about making the thing working because you are going to lose money if your manufacturing plant stops working, right? And in other cases, it's about safety. That you need to you are touching systems or you are connecting systems that have implications that can affect human lives. So going back to the building. When you connect a building to the internet and it's able to remotely control the building, what do you think, Eric, that are the problems? What are the main characteristics that you have to conserve in that property, in that building? Would you say it's making the building usable or making sure that the elevators, for example, doesn't harm human life?
Right. Or, of course, privacy of the individuals staying in these rooms if you do have sensors that are able to record their activities to some extent.
So when I did that and I presented in conferences, what every reporter asked me was, could you get into the logs? Why? Because that changes their perspective. It is, if you can get into the logs, it's not IoT anymore, security, because the more harm you could have done there is like to say, to annoy people, to switch on the lights, to put the TVs on. But the moment that you get the logs up and you can harm people, you can make or steal things from people, so they are affected, their safety is affected. And hence, that changes the whole perspective of the situation. I'm not going to go into details about the logs of that particular building, but what I mean is that for me, there is no question that even whatever technology you use, this is industrial IoT. Because you are connecting a network which may affect safety, and the reliability of that network is important too. The logs need to work correctly in order for you to experience that thing. That is a little bit of a gray area. It's that IoT because there are devices and lights, or it's industrial IoT. But there are things that we protect at Waterfall that is much more clear. When you go to a nuclear power plant or you go to an oil and gas refinery or an offshore platform, you really don't want a bad guy there to be able to access the pipes and be able to change a setting which makes the oil spill, right? The reliability and safety are paramount there. So we're talking about an industrial IoT system. And the way we treat security is much different or way different than the way we treat security in our world, which is all about the data. Don't lose the data. And encrypt the data. Make sure the data is safe. I don't want my records to be in the internet. So there is a big difference here. What we are trying to do at Waterfall is to make understand that where we're coming from is a world which is not about the data, but about the physical system. Making the physical system be reliable, making the physical system be safe to use. So that is the difference for me in what an IoT system, a system that has a specific requirements of safety and reliability that need to be preserved when you are connecting the system to an IT or cloud system, versus trying to preserve data, which is what we are used to. So it's a very different how security should be taken into account there.
Jesus, can you just talk for a minute about who the bad actors are here? Because I imagine if we're talking about an IT system for banking, we might be talking about criminal elements, and their motivation would be to hack into a system in order to access money. But if we're talking about a power plant, are we talking more than around military bad actors, around potentially other corporates that might be trying to interfere in operations, or who would be the bad actors in these? Because it seems like there's not in this case, a direct financial benefit for somebody from hacking in. It would be more of somewhat of a strategic objective to hack, or just potentially to cause some sort of anarchy, which might also be an objective.
There is a big difference on trying to get into an IT system and trying to get into an industrial system. And I'll tell you the difference. The difference is it can be easy to get into the industrial system, but the payload is very difficult to build because no one has built that payload before. When you go to an IT system, you have to find the credit cards and put them in somewhere, or the bitcoins. You have to find data and steal it and put it somewhere. That is the concept. You have ransomware, you find the data and then you encrypt it so they cannot find it. So it's all about finding the data you want and do something with it, either steal it or encrypt it or that. When you go into a nuclear power plant and you're able to get in, 99.999999% of the hackers in the world don't know what to do with it. What do you do when you do a nuclear power plant? In order to do any harm, you actually have to understand very well the physical process underlying it. So it's only while attacking and maybe entering the system may have a certain level, and we know now that lots of energy power plants in the US have been hacked already, but there is no payload yet, and this payload can only be created today by nation states or people with a lot of power. I don't know if you know about Triton. Do you know Triton?
No, I haven't heard about it.
Okay, so Triton is a payload, we'll say, that affected safety systems. Safety system is the last line of defense of an industrial site. In this case, it was an oil gas place, and these safety relays are the last line of defense. When everything goes wrong, we have to stop the process from continuing, so to say, that's it. As we know now, the people that created this malware, Triton, were able to get into the safety devices, meaning that they will have been able to stop the plant from working. And with that, they will have been able to make out of money, because if they were able to get there, and they will have been sabotage it and make it not work for days. However, rather than trying to do that, to sabotage it, so the safety systems actually blow and they are enforced, so the stops working. They wanted to hack the safety systems themselves. So they wanted to learn how to upload firmware to these safety systems, because obviously they were people that they weren't interested about money. They were interested about creating harm to people. They wanted to make sure these safety systems, they didn't make their work. And so you were able to release oil or do whatever these safety systems prevent you to do. So to make sure I'm clear about it, these people were obviously nation states, or somebody that's with not interest about money, but interest about making damage, So it's interesting that these actors right now are powerful actors that are trying to do bad things. That said, what happens always, and when 8 years ago, I remember I wrote a white paper, or more than that, 9 years ago, about ransomware. I said, why cannot create a virus which use private and public key cryptography in order to profit? And people thought I was crazy. And people thought that only the military would do that, because private key cryptography is complicated to use in these settings. Well, guess what? Now every mafia, Russian mafia, is doing it, and that is what's going to happen with industrial systems. Now people are doing Triton and doing the payloads that are able to upload firmware into the safety systems. Once this is done once, somebody's going to copy it, and he's going to copy it again and again and again. And in 8 years, the mafia guys will be doing it. So that's why we need to rethink, because now we're not talking about data, about money. We're talking about safety and human life. So I think it's a little bit more imperative for us to not to wait till these guys have this knowledge of the payloads that they can do to make harm, and they make ransomwares which will just make the current ransomwares of data be like the easy life we used to have, right? So we need to be a little bit aware of that.
Clear. And then the challenge with, certainly one of the challenges with IoT or industrial IoT systems is that the attack surface, or the number of attack vectors, is quite broad, right? So you can attack the hardware directly. You can go in through the cloud or through basically a lot of different endpoints. What is the role of cryptography, authentication systems? You mentioned that in this hotel, they were more or less non-existent in securing a system. And then if you can talk a little bit on this concept of kind of securing the full stack or designing in software so that it's not kind of, for most, I'd say most people's experience is that you buy a piece of hardware and then you kind of slap a security system on top. And my laptop has enough computing power that I can then install a nice heavy piece of security software, and that will do a pretty good job. But if you're talking about a small endpoint somewhere, you're probably not going to be able to, even if you had the insight to install proper security on that. Correct me if I'm wrong, but I think a lot of people also will just not think to install security system on top of their IoT devices because it's just not. If you think about routers and so forth, or connected cameras, all of these devices, it's not something that people typically think is required.
I want to quote one of my fellow workers, Andrew Ginter, which has a great book about SCADA security and how to fix it. That's the name of the book by Andrew. His point here, and I want to make it very clear, is no system is secure. That's we should start with that, because in computer security, and if you go to RSA or any of these big conferences, you will see full security, best security, the security like foolproof. That's not true. No system that you can create can make a system secure. Security is an overused word, no system is secure, and there will be always a way to go into that system. It is the way it is. In particular, and I will say that people believe that data, which is software, can make you more secure in general. And the truth of the matter is that every software that you create has bugs. And every bug is a vulnerability. And a vulnerability can be exploited to take over your system. So any bit of data that you let your device consumes may be a vulnerability or may be a hack. So you have to change this mentality of I put a firewall, which is software, or antivirus, which is software, and I will be more secure. In general, you probably will be as secure as before, or maybe less, because firewalls lately has like a lot of bugs, a lot of vulnerabilities. I am in a position to enter all your system. I want to explain that to you first because a lot of people ask me about cryptography. Can cryptography save us? Can access control save us? Can making... and the truth is that most attacks doesn't appear because of the lack of this kind of cryptography. Most attacks in the current kill chain, so where you are in the stack and how low you want to go in order to achieve your targets as a hacker, comes with phishing attacks. You say, oh, fine, mails, you should be able to read your mail, right? And then you open something which you should not open. They get your certificates, which are very good and encrypted and all good, but they already have your password because they can put a keylogger. So that's it, you have the certificate and the keylogger. And then the channel from the house or the VPN that the guy has is encrypted too. This is all also encrypted. And you arrive to the place where you're supposed to be. Everything there works as expected. However, if you are going to, with this link to a system which has safety and reliability considerations, then you can stop it. And then you can stop the system from working. Again, this is how this works today in the current world. It's pivoting attacks from one network to the other network because they create credentials, and the credentials are cryptography, and they are all good. Everything is good. But what is lacking here is a little bit of understanding that every bit of information that you let into your computer, in this case a mail, can be a vulnerability, and you can get hacked, and then you can escalate the attacks. So adding a ton of more encryption and cryptography and all these things will not resolve the current problem we have with security, which is hackers are abusing, not cracking, but abusing the system of credentials. So we need to be very careful with somebody telling us that, oh, I'm selling you this and credential system and it's going to be great, because usually it's not going to be great. Our approach at Waterfall, how we protect systems for places which require this kind of reliability and safety that no one else can provide, is to allow only data to flow out of the system. We use unidirectional gateways which What they do is they collect the information that you want to share in the nuclear power plant, in the signaling systems, information about your PLCs, or your historians. And we have a cell, a photo cell that only sends, and a receiver that only receives. You cannot do reverse. It's physics. This light goes only one way. It's a fiber optic cable. And what we do is, through that one-way link, we replicate from the industrial side information, whatever information you want to replicate, to the other side. So the IT system or the cloud system can use this information without having network or any kind of access to the industrial side. That's how we do it in Waterfall. That is the core concept of information. You have to prevent information to go in your perimeter if your perimeter requires safety and reliability regulations. Now, that said, there is obviously ways you can do that too. For example, Google, that has full control of every device that exists in the perimeter, they can insert a chip, a TPM chip like a trusted platform module for the people that doesn't know, or a root of trust, a hardware chip that is able to authenticate between the two, the keyboards and the rack, and is able to authenticate between the different hardware they have in the warehouses, wherever they are. And that way they can get rid of every firewall or anything that they want to put in the middle. They can do that because they can control every device that they have in their network. So they can communicate using the strong crypto, use a strong authentication, and all that. So if you can create a system which you control different elements of the system, and then you can try to use credentials. Now, when it comes to systems that require, again, reliability and safety, our approach is to say, what things do you want to share? The internet was built on the concept that everything has to be bidirectional all the time. Things need to talk because we are humans and we want to chat and we want to receive a chat back and send an email. But machines are not like that. A machine is not like a human. They send things at certain intervals, and we know the interval. They usually send information. They can receive information to change, in particular, these machines to control the behavior. But usually that comes from the perimeter. It doesn't come from like a remote place in the cloud. It can happen, but you can send this information through a very, very restricted channel. So it depends on your application. Obviously, if you need an application that needs data back and forth all the time, then obviously you have to use what Google does, like use or whoever or other company that does use a very hardened system, maybe use a trusted platform module, or use strong authentication, obviously, credentials, PKI, the whole mile, that is great. But in many, 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 many industrial sites, what you want to send is information out, so you know the status, and you can do things like maintenance of your PLCs and of your valves and of your train. But you don't require that much data to go in your system because that changes. And if you have done controls in colleges, that changes your considerations for the system. Any data that goes into the system makes it different. And if that system is a system that requires cyber physical considerations, then you need to restrict as much as possible data coming in, because that will change safety and reliability.
Jesus, how would you approach a use case like the connected vehicle? Because there you have basically weapons that are millions of them on the road driving around that can be used to hurt the people inside or outside, whether it's a truck or a consumer vehicle. And you have potentially devices that have to communicate not only with other devices. Let's say Google has their Google Taxi and they have 10,000 of those in a particular city. But then you might also have city infrastructure that needs to communicate with Google's system. You might have other, maybe Uber's system that also needs to communicate. So you might have different companies that are putting these fleets of vehicles on the road. And in order for them to operate, they need to communicate across fleet and also with city infrastructure. And so it's probably, on the one hand, you need data, I would imagine, input and output. And it's probably more challenging than this Google example that you gave previously, in that it's not necessarily just one constrained system that one company owns, but data is flowing across systems. What would your approach be for this type of company?
That's a great question. And the answer here is, first, you have to know what data is. When data affects data, what part of your network is about exchanging data, information, what kind of network in your system controls the cyber physical system, and of those, what are control things that can affect your life, like brakes. As it turns out, what they told you about in cars, people are using similar systems as I described what we use in nuclear power plants, or are thinking about using that, but in the car. As you know, cars have been hacked. It's very well seen. You can see now in the TV. These guys that remotely were able to stop the car. Chris, it's like it's something that they knew they could do it. We all knew because the way things were connected or cars have been connected is reckless. You put like a system which has like brakes and like can speed up and can kill somebody and connect it to the internet, and that happens because you are assuming that people cannot pivot between networks. But these guys, Chris, Vasilek, that was able to pivot between networks easily because there's always flaws. There's always software has flaws, and you can go from the CD-ROM in this case and hack it, and then the CD-ROM is connected to the CAN bus, and the CAN bus you could use the brakes. Now let's go to something that I am much more familiar than a car, but the concept is the same. A train rolling stock, which they used to call, they want to call it in that vertical. A train has basically three networks. The three networks they have the train is the train control management system, which is what affects the brakes, affects the speed, the computing capacity, which is where the onboard computer of the train is, and the infotainment. Right, the infotainment is where you see like the alarms, like saying like, oh, next station is this, and you see all these TVs, screens, and stuff. Now it's clear that infotainment, which is also where you have the Wi-Fi, this network is connected to the internet, right? Because you want Wi-Fi, so you want to connect to the internet. Now, should the infotainment be connected directly to the computing capacity of the train? That's the part of the train that makes things like opening and closing the doors of the train, for example. There's a computer there that does that. Should you be able to access for the infotainment that? And the answer is no. No, because you should be able to go into the Wi-Fi and be able to open the door of the train while somebody is leaning on it. What makes sense for you is to maybe send things from the computing capacity of the train to the infotainment, because you want to say, for example, there's a malfunction of the train. They want to, or you want to tell people where are the next station with, or if the train is late. You want to let them know directly, hey, the train is late. It will be like 5 minutes late. Nobody has to go there. A human has to go and tell people what's going on. So it makes sense to connect the computing capacity one way to the infotainment, but the infotainment will never be able to access directly the computing capacity. Now, when you go to the computing capacity to the train control management system, or in a car, in a normal car, a vehicle, where the brakes are and the wheels are and everything, to the computer, there has to be an exchange between these two systems. Obviously, you have to be able to break the computing capacity to be able to break. Now, the new regulations of the US, for example, they have to install what is called positive train control. That means that if the train receives information that suggests that the train is speeding or not stopping where it's supposed to stop, the computing capacity of the train automatically will break the train. So a computer now has much more access to the train control management system that they used to have. That's something that only the guy there could do. But now, because there was these fatal accidents in the US, it was enacted that at the end of this year, every train in the US needs to have positive train control. What you are doing, though, now is having the computing capacity, the computer of the train, connected to the outside, because they need information about the GPSs, about balises in the ground to know the speed and stuff like that. So you have a lot of communications that go into the train, and they have access to the train control management system. When I talk about people about positive train control, everybody says safety will be improved because we will not have these accidents that they used to have. However, we know for a fact the cybersecurity of the systems has reduced enormously. We have opened so many holes there. So obviously this information that is going to be exchanged, this computing capacity and the brakes, etc., which right now is kind of unrestricted, to be more restricted. How do you do that? So again, we're going to use software to protect that. You need to use ways to regulate the information flow between these two systems. Send information out whenever you want, because this is not going to affect the system, but the flow of information in should be at different intervals, should be well understood, what can be sent, and if something is sent that is not be sent, then it should be prevented. So that is how I will resolve that. This part of the system, such as the infotainment or, in the cars, information they received about, for entertainment of the user of the car, like music, that yes, to be connected and things to be exchanged between cars, yes. But when you go down the stack and you go more and more and more to a place where somebody can die in the process of a computer being hacked, you have to be more careful about the information exchange, about what kind of things of processor you have, about all these things. So that is how things will work.
So if we use this train example, I guess this is kind of two questions. One is, where should security be implemented? And two is, where is it actually implemented today in terms of who your customers are? So if we think of the device manufacturers or the component manufacturers, I guess ideally security would be built into every component that's put into this, but that's probably not often the case. Second, it could be the system integrators. It could be Siemens that's kind of building the engine, and they could be trying to build security into that. Or it could be the end user, the actual operator of the train system, and they're probably the organization that should be ideally least involved here, because they have the least, I would assume, the least insight into securing these components. But maybe they're the ones that actually have to do it because they're responsible for the safe operations of the system in the end. What does it look like today in terms of where security actually is being implemented, and where do you think there should be in a more ideal environment?
I think positive train control is like an absolute example of where security and who is in charge of security. Everybody doesn't want to deal with security. It's a pass the buck kind of thing. It's like, you do it. Because what Congress has told me to do is to enact a system that is able to break when the train speeds. They have not told me anything about trying to do a system that does that, but also has in consideration the fact that now I can go to the 220 megahertz peak frequency that these guys work in, and is able to send information there that may affect the train in other ways and open a bigger hole that that is trying to protect. Nobody has told anybody that, so nobody does anything about it. Everybody does a little bit, obviously. I'm not saying that the people that provide the communications don't do the due diligence and try to make the system as hard as possible, or at least make sure that there is tools in order for whoever comes down the stack has the tools to make it secure if they want to add like a chip there, or like add more certificates. The truth of the matter is that I am not going to go case by case. I'm sure that some of the people that have implemented positive train control have done a great job securing it. I'm certain. I'm certain too that there are people that they have not. So who is in charge? In charge is always the operator, the end user, the guys that put things together. In the case of the trains, are the train operators. That's the guys that at the end are going to implement this. So they are the guys that have to say, we want this. If they don't want this, they're not going to sell it. It is because they have a tight budget. They know that they will do what they can. What they have. The guys that can enable them to do that are the providers of the product. You provide a onboard computer, provide something that has a TPM or something that has a security chip there, so they can build on top of it. And obviously, as the security providers, which are contacted, and we are routinely by them saying like, hey, we have a problem here that is, we don't know how to have a problem. We know we have a problem. Can you help? And in our case, we help wherever we can. So there is a little bit of everything. However, I have to say that when it comes to industrial security, as people work with a budget and they have not seen the payload, they have not seen anybody jets blowing up a train by, again, I'm a person that hates this fear of things that are not easy for hackers. Hackers will have to do a lot, and it's complicated, and most likely will be seen. Maybe, my lifetime I will never see any disaster, big disaster because of server hacks. However, I have to say that, again, whoever, the person that has to take care of things are the operators, the people that build the cars, people that operate the rail, the networks, and they are the guys that have to, at the end, say, yes, I care about this. And the easy way to do that is by regulation. Nobody likes regulation, but, for example, nuclear power plants are heavily regulated on how they can connect to the wall, and that's why we are big there too, because they understand we're the best in security in that space, and they are regulated, so they need to the choice is easy. Others that have other more difficult choices because there is no regulation, then they may implement better security or worse security. However, I think at the end of the day, there has to be a little bit of common sense, but also in certain industries, regulation is necessary. When it comes to human lives and when it comes to safety and systems that are putting out there and controlled by computers and can be hacked with certain type of simplicity, not somebody has to say that there has to be some regulation on how this is done.
One last question on regulation. So certainly regulating particular industries and whether the levels of security there is one approach that is very important and probably will happen in specific cases. Another approach or another concern is that you have a lot of IoT devices that are maybe in themselves not particularly important. So a security camera, a connected DVD player, anything like this. But when you have hundreds of millions of these or billions of these in the world, they become then potentially the army for a botnet that can do real damage. I know this is not necessarily your domain of expertise, but do you see at any point in the future there being regulation that would actually hold the manufacturers of IoT devices responsible if their devices are hacked and used in botnets? Do you see this regulation to basically enforce device manufacturers to secure their devices so that they cannot become weapons?
Yes, I actually see that happening. And again, that really depends on if somebody finds a payload which is important enough for people to care, right? But in the last meeting of the industrial, the Security Working Group, I said, and that's my personal opinion, and that's again, my company doesn't work with these small devices, but my personal opinion is there is no reason why a camera should be able to send FTPs or send mail to do spamming. There is no reason why a user electronic has the same access to the internet as a human. Makes absolute no sense. I understand that these are computers that are based on computers that the humans use, meaning that they believe that they have all these ports open, 21, 27, who knows what kind of protocol is in that port. But usually what happens is these cameras reuse whatever crappy software is used for mail servers. They reuse it to put it there, and then this camera is actually a multi-purpose computer that does mail, can send mail, you can run anything you want, and connect to any website or any IP address or any person in the world. That is absurd. It is something which is, we're using it because we used it 7 years ago when the internet was about connecting people, not connecting people through machines, but not about connecting machines to machines. Machines to machines, they don't need 25 ports open. There is no reason to have all these ports open, connecting all these different protocols. You only need one communication, machine to machine, and one communication back. And the machines will not be able to go to the internet and browse porn. Makes no sense a camera browsing porn. Why? So at some point we should get in our senses and make devices to a definite purpose. So a camera should be able only to do this. And if you find a camera and you have some kind of chip or module that tells identification number for that camera, because a camera is not a user, it doesn't have privacy. If that camera is connected to a website, means that something is going wrong, and you should prevent this camera to connect to a website. It is very easy, actually. You say, well, this is kind of you're dreaming here because you're just have some crack before doing this podcast. But the truth of the matter is that any person that puts out a device that doesn't have some sort of hard identity or hardware identity is making a mistake and needs to be regulated. Every device that connects to the internet that has not to be manned by a human, like a laptop or anything else, like a camera or anything that is like a light in the streets or whatever, to have some sort of identification. So these cameras will only talk with other cameras, or cameras will talk only with our server that are supposed to see that. And it's just easy. It's not a difficult thing to do. We're not doing it because we are lazy and we want to reuse what we are using before. And this will what happens is that people create botnets with cameras, or is running in a fish pond which has lights, is running a Bitcoin rig. Again, this is because we are not using correctly these new IoT devices. Again, this is my personal opinion. It just makes no sense us using the same internet rules that we use because we wanted to have all these different things for a human to communicate for devices, which should be very simple. You send information about the video stream and you receive tilts and pan things that's it. You should not be able to send or receive anything else. For me, it's quite straightforward.
Makes sense. Yeah, it's kind of a pure tragedy of the common situation, right? Where the manufacturer of the camera that gets hacked doesn't necessarily suffer anything. They maybe have potentially a hit to their brand equity, but if they're a Chinese manufacturer, maybe even not. But it's whoever is getting hit by that botnet that suffers. So you could say it's society at large that's getting hacked more frequently. So those are, I guess, situations where regulators step in.
And again, when you make regulation, you have to be careful, because I heard people saying like, oh, we are going to make this regulation that forces all IoT devices to do X, Y, Z. Well, again, you should differentiate what is the purpose of the IoT device you're talking about. Because if you're telling me that you require encryption and whatever in the IoT device, that really depends on what kind of purpose this device has, and what other devices is communicating with. If it's a device that is going to be set up in a place where safety is involved, you should not have this device be in the same place than a Barbie. Again, Barbie needs to be usable, but that you need to understand that, so you don't also cannot put like there and it has to be cheap because it's a toy, so you need to put IoT devices in different spectrum of responsibility. And but the minimum responsibility that we need to take care of this is, again, devices that have a task to only be able to use the connectivity that we provide them to do that task, not to do a multi-purpose task that anybody can abuse. That is problematic.
Well, that I hope is the direction that we are going. I guess this is a challenging topic, I think, for regulators, but I know that you and the folks at the IIC are doing your best also to communicate out from the industry to the different regulating bodies.
In the Security Working Group at the IIC, we already have put the documents. We started with the security framework. Now, 2016, we released 2015-16, we released it. That was an informative document, provide a lot of good information about understanding better what the industrial IoT is. Lately, we have done the best practices for endpoints, which is a document which explains how you should create an endpoint which will be in industrial IoT. There are different levels of security. We obviously describe how to put a strong identity in a device, things that are common. In the future, we are going to release, and hopefully at the end of this year or maybe early next year, the industrial internet maturity model, security maturity model. The security maturity model is a way for create targets that a system should have and be able to achieve them by following different maturity levels. So you have achieved maturity level 1 or 2, etc., and increase your visibility on what is your status on because at the end, the most complicated part when you are given a big project is how to start. Well, what I do now, I have all these cameras that are connected to the elevator, and the elevator is connected now to the cloud, and you need to understand a little bit what are your targets here, what is your focus, and be able to achieve them. Again, nothing is secure. You always make mistakes, and but you have to be able to understand the risk you are taking, and the maturity model is going to be, I think, a game changer in the way we understand risk, understand the maturity of a system when related to security in industrial internet, because we are focusing in, again, industrial internet, not the IT side of things, but the industrial side of things. So I think that's with that. And hopefully also next year we will release a new version of the security framework which takes into account things like reliability, safety, that are so interconnected with security. And in this podcast, in the last minutes, we have discussed a little bit about it, of how a train is no different than a Barbie, and a connected Barbie or connected toy, and is different than a connected light, which probably that has different requirements. So this is something that should be intertwined in security. Security cannot be seen anymore as a data thing. Oh, I'm going to secure the data. It has to be how to provide cybersecurity so safety is not impacted, and how to provide cybersecurity so reliability is not impacted. Data can be lost, but we are talking about other things in here when we talk about industrial.
Great. So yeah, we'll definitely link to these IIC documents in the show notes. Jesus, where is the best way, or how is the best method for people to follow up with you, whether it's to learn more about the IIC or about Waterfall Security?
Well, my email, which is Jesus at waterfall-security.com. That is my email for Waterfall. And again, I will encourage anybody that is interested on joining the IIC. I think it's a great place right now, in particular for end users, people that I've been now working with industrial internet systems for a while now, for years, and I understand that things are slower than people thought. Because, and there is a reason for that. It's because what I'm saying, people don't want to in particular in systems which you care about reliability, like discrete manufacturing, for example, you prefer to put things at the edge that makes sense. But the truth is also these things will trickle down slowly, but you can wait. But at some point, the benefits of having your systems more connected will increase. And joining the Industrial Internet Consortium, which we have been working on this for years, will be a great help. We have testbeds which you can join in order to evaluate your products or understand how others have done it. And also we have great talent and great understanding of how this works. I think joining the Industrial Internet Consortium is great. If you are in a vertical where like safety and reliability is critical, such as rail or airports, oil and gas, I think it's if you have something you want to connect, I think Waterfall Security, my company, will be great to help you on that. So that is the two places that I believe it will be good for the listeners to get more information.
Great. And just we'll certainly put all this in the show notes, but let me just do a final repeat for anybody who's just maybe listening to this while you're on the road. So Industrial Internet Consortium, that's www.iiconsortium.org, and then Waterfall Security, www.waterfall-security.com. Jesus, thank you so much for taking the time to talk with us today.
Well, thank you very much, Eric, for your great job. I think all this podcast is great to get more in-depth information about everything IoT and industrial IoT. And thank you for having me. I hope I did a good job trying to explain my view, which again is maybe not shared by a lot of information security professionals, because I come from another place. But I hope that helps the people understanding why we care in a different way about security when it comes to industrial IoT.
This episode of the IoT Spotlight was brought to you by the Industrial Internet Consortium. To learn more about their joint testbeds, white papers, and other collaborative activities, visit www.iiconsortium.org or reach out to me directly, and I'll be happy to make an introduction.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.